Hey everyone, it's Actuary Dude over here. We'll do another question. I've actually already gone through it because I tried to make the video, but then my phone went off in the middle of the video, so I'll just run through exactly what I've done, and I think it should be just as effective. So a university student receives a 3-year sponsorship grant. The payments under the grant are as follows. In the first year, £5,000 per annum are paid continuously. In the second year, £5,000 per annum are paid monthly in advance. And in the third year, £5,000 per annum are paid every half year in advance. So we have to calculate the present value of these payments at the beginning of the first year using a rate of interest of 8% per annum convertible quarterly. This is actually not very complicated, if you can, I guess, kind of see it. So basically what we've been given is that I to the 4 equals 0.08 or 8% per annum. So we need to find out what the effective interest rate is. So all we're going to do is we do 0.08 divided by 4, which is 0.02, and then we compound that over 4 periods, and this is what we get. We get 0.082936. I'll just show that's this. This bit is the effective quarterly rate, and so what we're doing is, sorry, I'll just bring this in over here. We took that quarterly rate and we compounded it 4 times, and that gave us 1 plus I over here, and then we just minus I, and so this is what it is. So it corresponds there. And then to find a continuous payment stream, so that's what it asked for, it said paid continuously, so we're going to have to deal with delta, and we know that e to the delta equals 1 plus I, so if we just take the natural logarithm of 1 plus I of this thing, which is what we did, ln of a2 over there, which gave us 0.072 and so on. Okay, so then that's very useful. Now on the other two payments, it says that they're both in advance. So when we're in advance, we're going to be using the discount rate. You can do other ways, but I guess it's probably better to follow things pretty strictly, especially when you're dealing in a case with a whole lot of numbers like this. So we find what d is, which is I divided by 1 plus I, which is fine, and then d to the 12. So how do we find d to the something? Well, d to the p equals p times 1 minus v to the 1 minus, and then it's 1 minus d in here to the power of 1 on p. Close the brackets there. So that's what I did over here. So I've done 12 times 1 minus d, which is a5, to the power of 1 on 12, which gives us this rate here. d2 is the exact same thing. All I've done is I've just swapped the 2 in there. 2 times 1 minus d to the power of 1 on 2. Then I found what v was, because we're going to need that for all the equations, which is 1 divided by 1 plus I. And then I got started. So what I did over here was that I found, okay, the continuous payment here is A paid continuously. We're just finding 1 year because they're each done in 1 year, rather than some people would probably take this back through, would make this go over 3 years or something like that. But that's not what's happening. They're each for 1 year. This second year, so when we're getting a payment for 1 year, we've got to discount it back. So this bit over here will take us from payments coming in the second year to the start of the second year. We need to bring it back to the start of the first year, beginning of the first year. So we multiply it by v, and then over here, this will take us payments to the start of the third year. We need to bring it back 2 years. So that'll be this bit over here, where we've got to discount it back 2 years, v to the 2, and then all of them is multiplied by 5,000. So very easy, we work it out. We just go over here, this is the first continuous rate. 1 minus, I think if I just do that, here we go, 1 minus v divided by, and that's v to the power of 1, but we don't need to do that, divided by delta, gives us that bit. Then the next payment is a due 12 in 1 time period. So all we're doing is we're saying 1 minus v divided by d12, and then we're going to multiply that whole thing by v, just 1 period there. We're just going back 1, so that doesn't even need to be there. And then we've got this one over here, which is this bit here. Sorry, I'll just take it back. There we go. So that is 1 minus v divided by d2, and then multiplied by v squared, which gives us whatever that is. Then I summed those 3, so that's what it became. And then I multiplied it all by 5,000, and that gives us the answer of 13,447.39 pounds. So I'll just write that down. May as well have that in the answer over here. So that equals 13,447.39 comments. And there you go, that's how it's worked out. If you have any questions, then please ask in the comments. If you don't like me doing it this way, then please let me know and I'll never do it again. Thanks for watching.